Hi, I'm Charlie Saccarelli, and today we're going to talk about refractive errors. So this is an eyeball, but before we get to that, I want to go a little bit into optics, but not too deep. I'm just going to talk about a little, maybe a childhood thing that you may have done, where you have a magnifying glass, and depending on your level of sadism, it's either an ant or maybe a piece of paper or grass. So for today, we're going to just we're going to draw an ant because it's more it's easier to draw rather than a piece of grass, right? So I'm an ant, and what we do with this is the magnifier, when you hold it at a certain distance, it collects all the light to a single point. And when you focus that point where the light is on that ant, what happens? Poof! You have a fire. Pardon my art. So that's how a magnifying lens works, is it collects light to a point. And the way that our vision works is we have a series of magnifying lenses in our eyes that ultimately acts almost like a projector to flip the image upside down onto the retina to be sent down the rest of the brain. We'll talk about the brain another time, but right now we're just talking about the idea of how these things interact to put a clear image on the retina. So there's three critical parts to the eyeball that kind of work together to make this happen. So the first is called the cornea. And then you have the crystalline lens. So the cornea is a very, very high-powered lens. So if you were to try to burn an ant with a cornea, a disembodied cornea probably, it would be about 2.5 centimeters, so less than an inch, that you would hold the cornea from the ant to actually burn the ant. So that's how powerful that lens is. And then you have the crystalline lens. And the cool thing about the crystalline lens is it varies in power. So when you are early in age, it varies more. And much like the rest of your body, as you get older, it kind of tightens up. So what happens is that this lens, when you're younger, it has a much wider focal ability. And as you get older, as it tightens up, it reduces its focal ability. So these two lenses together, so this lens is a fixed power, this lens changes in power. Why would it change in power? Well, because sometimes you want to see far away, and sometimes you want to see near. And what happens with this lens is, as you want to see near, this lens will flex and grow in size to make the lens more powerful so that you can focus it near. And then when you look far, the lens will relax so you can look far. So it's almost like a zoom lens on a camera, only more moist because it's a body part. So these two things work together in tandem to broadcast a clear image onto the retina. So these two lenses, what they do is they work much like the magnifying glass, and they focus light to a point right behind this system, which then flips upside down, and the image that goes onto the retina is an upside down image. But right now we're not necessarily worried about the upside downness so much as we are the clarity of this image that's broadcast onto the retina. So when these lenses, so basically, if you look at this, to focus the light perfectly onto the retina, these two lenses need to be adjusted pretty perfectly to focus on a very specific point. So if they focus on that point translates to it being a perfectly clear image on the retina. Now, what if these two things focus here? Or what if they focus here? Or what if they, rather than focusing to a point, they focus to like an oval? So those scenarios are called refractive errors, and we're going to talk about 4 different forms of refractive error. So the first is called myopia. The second is hyperopia. Third is astigmatism. And fourth is going to be presbyopia. These things can all kind of happen together. So depending on your refraction, you could have astigmatism with presbyopia. You could have myopia with astigmatism with presbyopia. You could have hyperopia with astigmatism with presbyopia. So basically, it's a mix and match of these various things that can all affect your eyes and all change how you need glasses. But we'll talk about each one individually, and then if you have like the mix of them, good for you. So what myopia is called nearsightedness, also known as nearsightedness. So when you have myopia, you have this ideal point where it should be focused, and then you have the clear image on the retina. And what's happening is that this system is focusing light too early before the point where it should be focusing it. So what we do, and I'm an eyeglass guy, so I'm going to talk about what we do with eyeglasses, and picture contact lenses kind of doing the same thing, but doing it right smack up against your eyeball. But glasses do it a little bit differently. So what we're going to do with glasses is we are going to make a lens that splits these light rays out. So instead of going straight in, now they're going to split out a little bit. And then when they go through the system, they focus on the perfect point rather than the early point. So when we make a lens, basically what we're doing is we're saying, okay, these two lenses aren't working as they need to, so let's add a third lens to offset the imperfection, and then those three lenses will work together to focus things to where they need to be focused. So that is how a lens helps you see clearly. Now I'm going to erase some of these images and then talk about hyperopia. And what hyperopia is that your eyes focus too late. So instead of focusing here, they focus here. And what we do with that is we use a lens that's thicker in the middle. And what that will do is instead of bending light out, it will bend light in. So then the image coming in still goes good and goes through the spot where you need it to. So that's how plus and minus lenses work. The other thing that we have is astigmatism. And what astigmatism is picture your magnifying glass, but instead of focusing it to a point, it focuses to a line. But you want it to focus to a point. So what happens with astigmatism is we use a lens that's called a toric lens. So what a toric lens has, and it's really hard to kind of draw on a 2D space, but it has two different focal points on it. So basically what we're saying with astigmatism is that you might have one spot on your eye that focuses there, and then another spot that focuses here. And it's really bizarre to try to explain in this context, but what we would do is we would make a lens that is two different curvatures. So you would have it this curve this way and some other curve in this way. So then when we're bending the light, we would bend it more in one direction than another direction and ultimately focus it to a point, which creates a clear image on the retina. So that's astigmatism. And last but not least is presbyopia. And around the age of 40, most people experience this. Now, what is presbyopia? So presbyopia is this magical lens getting a little bit frail. And what happens is it doesn't flex the way it used to. So what that means is that we need a little bit of extra help at near. So if you've ever looked at your prescription and your prescription has some stuff on the top, it has a sphere, a cylinder, an axis, and then the bottom has an add power. What the add power is intended to do is help this lens, help that lens with its lost ability to flex. So that is what, those are the refractive errors. And ultimately, when we make glasses, when we make contact lenses, what we're doing is we're making a compensating lens that will offset the imperfection in these two lenses to ultimately focus clearly onto the retina. So that is us talking about refractive errors. And I'm Charlie from Chadwick Optical, and I love you.